Hello everyone. I wanted to work a systems word problem in a little more detail than I did in my other video in which I show the way to hack these problems. Now you see the link for that video because I'm using those ideas to help me solve this one. So watch that one first and then come back and watch this one. Alright, what I'm calling this a peppermint patty problem because Charles Schulz of Peanuts fame had his character, who Peppermint Patty was notoriously bad at school, ponder this word problem. And it is a convoluted mess. It's enough to give anybody a headache. Peppermint Patty reads it and she says, "Ma'am, would you settle for 20 push-ups?" Which is a very reasonable question on her part. Now, I'm going to read the problem, but not in a way that would confound Peppermint Patty. I'm going to omit some of the information. And by doing that, I get at what I call the simple sum. In fact, it sort of just stands out at you. I'm going to eliminate the percentages of butterfat and simply read it like this. How many gallons of cream and how many gallons of milk must be mixed to obtain 50 gallons? Now, that's not the way the problem reads, of course, but I've gotten rid of information that's cluttering up me seeing this essential simple sum that exists in almost all of these system word problems. How many gallons of cream and milk must be mixed to obtain 50 gallons? So, if you don't see the simple sum, what I suggest you do is draw a picture. Even if you do see it, this is a great idea. A problem of this sort, you might not think you could draw a picture, but you can. You can make up some vats that contain cream and milk and the mixture, and you know that a certain number of gallons of cream and a certain number of gallons of milk will go together to create this mixture, which we know from the problem is going to have 50 gallons. So you draw your picture and you start filling it in with the details up above in the problem. Now, we don't know how much cream there is. In fact, the problem says how many gallons of cream, and the problem says how many gallons of milk. I'm using question marks here, but you know ultimately we're going to have to go to variables. And so that's another clue to solving these word problems. The first one was, if you're dealing with systems, go for the simple sum first. The second clue is always draw a picture if possible, and it's almost always possible. Another clue that I talked about was simplifying the problem by omitting some of the nasty detail. And then a fourth clue is to do variable declarations. Let me create some space for that here. In other words, I'm going to define my question marks. And when you do that, I suggest you be a little bit more descriptive than the textbooks normally hint at. In other words, what I suggest we do here is let's let C be the number of gallons of cream. It makes more sense to me, and it simplifies the problem if your variables match up with what they're describing. They are descriptors. And so I'm not going to use X or Y or Z. I'll let C be the gallons of cream. And how about I let M be the gallons of milk? That makes good sense. It's adding one less piece of complexities to keep your descriptors descriptive. Okay, now, so I think we're ready to get the simple sum here. We have C is the number of gallons of cream, and we know M is the number of gallons of milk. Together they have to make this mixture of 50, and I'm hoping that you do in fact see this is our simple sum that I talked about so much in that other video. The gallons of cream and the gallons of milk go together to make 50 gallons of milk. Now, since there's infinite number of solutions to that problem right there, whenever you have two unknowns, to nail it down to a specific solution, you need two equations. Two equations and two unknowns, and three equations and three unknowns, and four equations and four unknowns. So essentially I need more information here. I need another equation. And that's the information I omitted when I reread Peppermint Patty's problem. That's the stuff up above that deals with butterfat and percentages. And what I suggest you do then is go back to your drawing and start piecing it together. Start transitioning the information that you find up here. For instance, this says, how many gallons of cream containing 25% butterfat? So cream is 1/4 butterfat. It's 25%. butterfat. And so I come down here to this drawing. I don't know how much cream is in here, but one thing's for sure, I do not, whatever is in there, 25% of it is going to be butterfat. So that's what I've done there. I said 25% of what's in there, of the C, of the cream in there, is butterfat. Similarly, when you go back upstairs here, it says milk contains 3.5% butterfat. Now I don't know how much milk is in there, but I know, going to a decimal here, that 0.035 of the milk that's in there is butterfat. Now what about the mixture? That's actually stated here for us. It says that 50 gallons of cream contain 12.5% butterfat. 50 gallons of our mixture, 50 gallons of it, and 12.5% of it is going to be butterfat, or 1/8 of it is going to be butterfat. So I can translate that, I can transition into math speak like this. And that's going to calculate out as a straight number once I do that multiplication. Once I replace the of with multiplication, 0.125 of 50. That is a hard number. And now when I look at what I've written in here on my drawing, I basically am staring at the second equation. And so all we need to do is replace the ofs with multiplication signs, and we do have in fact our second equation, which looks like this. Two equations and two unknowns, and essentially this is solvable by elimination or substitution, or by using a software package, which is what I want to do to save time right now. I'm assuming you know how to grunt these out using substitution and elimination, so there's nothing to be gained there. Instead, I'll show you Wolfram Alpha. I've already put the two equations in there. Notice the comma separating the two equations. And let me hit return. And let's see what it says here. I scroll down, there you go. 20.9 gallons basically of cream and 29.07 of milk go together to make a 50-gallon mixture that's 12.5% butterfat. So that's how you solve these problems. One way. I had 4 key hints for you in there. One hint was to read the problem first in all its complexity and then rip out some of that complexity. I got rid of the 25% butterfat and all the other percents. And the reason why I did that is because I was going for the simple sum, which is another major hint. The third idea was to draw a picture even when you don't think you can draw a picture. And then the fourth idea was to use descriptive descriptors for your unknowns. And then, of course, again, get the simple sum first. And then use the other information in the problem to fill in your drawing, transitioning into sort of like a in-between place between the formula equation and English language, which is what I've done right here with this language. Okay, well, I hope that helps. There really is no simple way to solve these. Ultimately, it's all going to hinge on your hard work, working them again and again and again, even working the same problems over and over again. But then there'll come a moment when it'll all click and you'll be able to handle these problems. I'm hoping this one gets you slightly closer. Talk to you again soon.